So yesterday we started with ratios and proportions. Now we're moving into our units and percents. So that'll wrap up this first part with ratios, proportions, units, and percents. We had a similar question yesterday, but on a much grander scale. This one's going to be a little bit easier, but I want you to kind of make connections between the differences in the type of information that was given. Okay? So we ended with that area scale problem yesterday, which we had to kind of adjust that ratio to consider the fact that we were given area and linear dimensions, but for two different things. So here we have an architect's drawing of a floor plan for a house. 1 inch represents 3 feet. There's our ratio. If a room is represented on the floor plan by a rectangle that has sides of 3.5 and 5 inches, what is the actual floor area? So we still have that same idea where we need to take linear measurements and turn them into an area. But this one's a little bit easier because we weren't given area. We were only given linear measurements. But the important thing to remember is that when we took that ratio of the linear measurements yesterday and we looked at the ratio of the areas, they were not the same. They were drastically different. And so you cannot take the ratio of a linear measurement and use it to find an area. So when we're given this situation, you're going to want to find the actual dimensions of the room first. You want to make sure that you know how long and how wide the actual room is using the information from the plan before you find the area. If you try to find the area of the plan first and then use that ratio to get the area of the room, it's going to be completely wrong. You can only use this ratio on linear numbers. Okay? This is a linear ratio. These are linear values. Now we can use these ratios to find the length and width of the room. So if I want to start with the short side and I have my ratio, what can I do to find the actual length of the short side of the room? Okay, can you be more specific?
3.5 times 5.
Same thing that we did yesterday with ratios. If I want to take that ratio and use that number to find the new one. Before we get there, set up our proportion first. What's my proportion going to be? We're starting with just the short side of the room. What does this 1 represent?
Inches.
What does the 3 represent?
Feet.
Do I know inches or feet? So what do I put up here? What do I put down here? Then you can solve. Okay? What is 3.5 times 3? 10.7.
10.5.
Thank you. 10.7. That was unique. So, ladies, is this going to be an issue? So, the short side is 10.5 what? Feet. Because we're converting inches to feet. So how do I get the next one? Same thing, same ratio, but what's going to change? Wrong button.
The numerator is going to be 5
There you go. Same ratio. Proud of you, Connie. Cross multiply, solve for x. Now that I know the actual dimensions of the room, now I can find the area. But you have to do that conversion first. If you're given 1 inch represents 3 feet, you need to convert your inches to feet before you find the area. So what's my area of my room now? What's the actual area of the rim? I want the area of the actual room, not the floor plan. 157.5. 17.5 is the area in square inches on the floor plan. But if you try to use that ratio, you're going to get a much smaller number. Yeah. So always do that conversion first before you find the actual area. Anyone here taking chemistry? Do you guys remember stoichiometry? Unit conversion? That's what this is. Unit conversion. Luckily, it's going to be unit conversion within the metric system, which makes things a lot easier. If you're going to have to do unit conversions within the standard imperial system, they'll give you those conversions, feet to miles, or if you're going from metric to standard or standard to metric, they'll give you that conversion, how many meters. But if we're going metric to metric, it's really easy. So we have the Pacific Plate, one of Earth's tectonic plates, is moved 1,060 kilometers in the past 10.3 million years. What was the average speed of the Pacific Plate during that time period in centimeters per year? So that right there tells us our ratio. Centimeters per year. That's our target. Okay? Length over time, but we're trying to convert kilometers to centimeters and millions of years to years. Well, the millions of years is the easy part. Centimeters to kilometers really isn't that bad either. But you need to understand how to convert within the metric system. Okay? Fun little mnemonic device if you don't know all of your metric prefixes. King Henry died by drinking chocolate milk. Those give you all the prefixes of the metric system. Kilo, kilometers, kiloliters, kilograms. H for hecto, hectograms, hectoliters, hectometers. The first D is for deca. B represents our base. Our base within the metric system is meters, liters, and grams with no prefix. Okay? If you don't know what those are, blame your science teacher. It's the base unit of measurement. So meters is the base unit of length. Here's meter. Okay? This is the base unit of length. A liter is a unit of volume. Gram is a unit of mass or weight. That's the base unit. So it all starts at 1. Okay? Well, if we go to the right towards deci, there are 10 decigrams in 1 gram. Deci means 10. Centi, there's 100 centigram in 1 gram. 1,000 milligrams in 1 gram. So as we move to the right, our decimal point moves once, twice, 3 times to the right to increase that value. So if we start with 1 in the base, we move to the right however many times for those place values. If we move to the left towards the larger measurements, okay, towards deca and hecto and kilo, okay, we're going to be moving our decimal point to the left. Oops, that was too far. So 1 meter is 1/10 of a decameter. It's 1/100th of a hectometer, and it's 1/1000th of a kilometer. So these are our larger values of measurement. These are our smaller values of measurement. So for length, meters. Okay, kilometers is like measuring in miles. Long length. Meters would be more appropriate for measuring height. 1.3 meters, 1.5 meters. Centimeters would be more appropriate for measuring how long a piece of paper is. Millimeters, much more appropriate for measuring tiny objects. And there's actually more prefixes beyond that for much higher and much smaller values. Now, if you're starting at a specific value and you want to end at another one, then you follow this path and say, okay, I'm starting at kilometers, 1 kilometer. Every time I move down a prefix, my decimal moves that direction. So then when I go from hecto to deci, I do it again. And deci to base, I do it again. So there's 1,000 meters in 1 kilometer. I do it again to deci. There's 10,000 decimeters in a kilometer. There is 100,000 centimeters in 1 kilometer. So if I'm trying to go from kilometers to centimeters, I'm going to have a whole lot more centimeters when I move down. So our conversion, we're going to start with our kilometers over 10.3 million years. And to get our kilometers to centimeters, we have to use this conversion. Well, there are 100,000 centimeters in 1 kilometer. So I'm going to set up, it's essentially a proportion. Stoichiometry makes it a little bit easier. And what I want to do is I want my kilometers to go away. So I know that there's 100,000 centimeters in 1 kilometer. 100,000 centimeters in the 1 kilometer that I started with. And what this does, the reason I have the centimeters on top and the kilometers on the bottom is because if I have kilometers divided by kilometers, those go away, leaving me with my centimeters. And then everything that's in the top row gets multiplied together. Everything that's in the bottom row gets multiplied together. Okay? Now, 10.3 million years into years, well, I'm having millions. How many years are in a million years? It's not a trillion. 1 million. That's your conversion. So, 1 million years has 1 million years. So my millions of years cancel out, and I'm left with the units, centimeters and years, in the spots that I want them. And so everything in the top row gets multiplied, everything in the bottom row gets multiplied. Now, luckily, using millions of years and the metric base 10 unit, that's really easy multiplication. You don't need your calculator for that. 1,060 times 100,000 is 1,060 with 6 extra zeros. I'm sorry, 5 extra zeros. 1, 2, 3, 4, 5 extra zeros. So 1,060 with 5 extra zeros. And then 10.3 times a million is going to give me 10,300,000. And to finish it off, we just need to simplify that fraction. Again, not hard math. You don't need all those extra zeros, because every time you have the same zero in the numerator and denominator, it goes away, goes away, goes away, goes away, goes away. So you're left with 10,060 divided by 103. Then you end up with so 10 point. So it moves 10.3 centimeters every year. That is very, very slow.
Did you like learn science?
I paid attention in high school.
Well, I think we're talking about the animal kingdom at first. Like the phylum.
Alright. One more conversion. County Y consists of 2 districts, One district has an area of 30 square miles with a population density of 370 people. There's your ratio, people per square mile. The other district has an area of 50 square miles and a population density of 290 people per square mile. What is the population density in people per square mile for all of county-wide? What information would I need in order to find the population density for that area? I need to know two things. Total amount of square miles and the total amount of people. If you want the people per square mile, you have to know how many people and how many square miles. That's our ratio. People per square mile. People per square mile. So if you want for an entire county, you have to know how many people there are and how many square miles there are. Well, they give us piece by piece. So they give us one district has 30 square miles and 370 people per square mile. So if I've got 30 square miles and 370 people for every square mile, how do I find out the total number of people?
Do you divide?
I'm not going to divide.
Oh, you add.
Multiply. 30 square miles, every single square mile has 370 people. So we want to multiply those together. 370 times the number of square miles. Oops, too many zeros. Keep doing it. 11,100. Correct me if I'm wrong, because I'm literally doing that from memory. Okay? So that's my first district. I have that many people. What about for the second district? Same thing, but with what numbers? 50 and 290 people per square mile, which gives me, oh boy, 14,500. Okay? So I know how many people were in each district. Well, now what am I going to do? Combine them, because I want to know the total. How many people do I have total? Alright? So I've got my total number of people. What else did I need?
Total square miles.
Okay. Square miles do I have total? Less than that. 30 in District 1. There's 50 in District 2.
Oh.
Add them together. There's 80 square miles. So I've got my ratio. I've got 25,600 people taking up 80 square miles. How do I find the number of people per square mile? Help. Oh. 320 people per square mile. When you get a denominator of 1, okay, you have a whole number, you get a denominator of 1, we call that a unit rate. So whenever you see things like people per square mile, miles per hour, centimeters per year, we're always a denominator that's a 1. We call that a unit rate. So when we're dealing with rates and ratios, unit rates are the ones that are going to be most common for helping us to identify, answer questions, look at information. So we end up with a unit rate of 320 people per square mile. Okay, so those are our rates. We did ratios and proportions. So now we're going to move into percents. We've done a little bit of percents already, so we're going to kind of add more into that. Most of it's going to be focusing on percent of increase or decrease, but it's also going to be kind of problem solving and understanding that percents represent amount of a whole. It's always out of 100. So that's our starting point to kind of look at. So today, Ibuka opened a new cereal box and he ate a bowl of cereal, which was 8% of the cereal in the box. Okay? So he ate 8% of what was in the box. How many more bowls of cereal can he expect to get from the box if he continues to eat the same amount every single time? Okay? So if he eats a bowl of cereal that's 8% of the box, how can I figure out how many bowls of cereal are in the box? We could, but you want to check every single one of those?
Get rid of stuff.
Yeah.
I mean, you can sit there and multiply 8 times 7, 8 times 8. But, I mean, that'll work, but what if we want to do it in one step?
Well, I don't know if I did this right, but like, if you take our goal is to be 8%, it's just gonna be, if you subtract 8 from 100, it's gonna be 92 divided by 8. It's just gonna be
If you take a whole box of cereal, I'm going to do it in a slightly different order than you did. You take a whole box of cereal. You take a whole box of cereal, you want to figure out how many bowls of cereal you can get out of that entire box. And each bowl is 8%. Divide the box by 8%. Divide 100% by 8. Now, here's the thing. That's going to give you 12.5. Okay? So the box contains 12.5 bowls of cereal. Ate one. So we need to take the one he already ate away because it says, how many more? He already ate one. So we take away the one he already ate, we're left with 11.5. Now this leads me into a note, a comment that I want to add. A lot of the questions, when I looked over them on the test, were close. So many of the ones that I hand graded is like, yeah, you almost had it. There was another answer that was very similar. You just happened to pick the wrong one. That would be the difference of picking 12.5 over 11.5. You understand the overarching concept. You get what the situation is talking about, but you miss some minute detail that led you towards the wrong answer. And so what you need to understand is that there's little things like this where if you forget it, your answer's still going to look right. It'll be there. But if you leave out that little detail, that's the difference between right and wrong. And so you need to pick up and carefully read the questions so that you're not missing any of those key details like how many more. If it just said how many bowls of cereal are in the box, it's 12.5. But they want to know how many more can he get. You can only get 11.5 because you already ate one. Okay, so I don't want you to be too discouraged. When I can give you back your test once the makeups are done, I want you to look through and see, okay, I got this one wrong. Is there another answer that's similar that would make more sense? And you can have that conversation with me as well if you want to clarify that and just learn to pick up on those details. And if you do that, you'll be surprised in the gains that you can make. Okay? Questions, comments, concerns, queries? All right. We'll pick up with the rest of the percents tomorrow.